Welcome to the Explainer. So, if you've ever thought of research as just this dry, dusty academic chore, endless piles of heavy books in a quiet library, we're going to completely flip that script today. We're reframing research into what it really is, a thrilling voyage of discovery. It's a very active, deliberate journey from the comfortable shores of what we already know, straight out into the exciting, uncharted waters of the unknown. Whether you're a student, a professional, or really just a curious mind, mastering research methodology is your ultimate navigational tool for finding the truth.
Okay, let's dive into this. Here's our itinerary for today's journey. First, the voyage of discovery. Then, mapping the research landscape, method versus methodology, the 11-step process, and finally, gathering data and sampling. We've got a highly structured map to guide us safely through all this, so let's get going.
Starting with Section 1, the voyage of discovery.
Now, what's really interesting about this is that absolutely nothing improves in society or in business, or frankly even in our personal lives, unless someone, somewhere, stops to ask questions and systematically seeks out the answers. This beautifully simple quote from Redman and Morey perfectly hits the nail on the head. They call research a systematized effort to gain new knowledge. You see, as a researcher, you aren't just wandering around hoping to stumble upon a new fact. No, you're an explorer. You're systematically venturing into uncharted territory, using a careful, organized approach to either discover something brand new, verify if a long-held belief is actually true, or reach a totally fresh conclusion based on real evidence.
Let's ground this lofty idea in some everyday reality, all right? Imagine you notice that some students in a class consistently score way higher marks than others. If you just guess why that is, like, I don't know, maybe you assume they drink way more espresso or they just have a secret stash of smart pills. Well, that's not research. But if you find out the real answer by asking structured questions, collecting evidence, and carefully checking that data against scientific procedures, that is the core of the scientific method. You're moving out of the realm of guesswork and stepping into verifiable truth.
Which brings us to Section 2, mapping the research landscape.
Just as every expedition needs a really good map before setting sail, researchers have to choose the right type of study before they even think about collecting data. And this brilliantly illustrates the first major fork in the road. On one side, we have descriptive research. This is where you act as a passive observer. You're simply reporting things exactly as they are right now, without trying to change a single thing. Think of, say, a simple survey asking shoppers which brand of tea they prefer. On the flip side, we have analytical research. Here you take facts and information that already exist, like a company's past sales records, and you critically evaluate them to reach a judgment, maybe to figure out which marketing campaign actually worked the best.
Next up, we need to contrast the immediate with the theoretical. So applied research, which sometimes gets called action research, is basically all about putting out immediate fires. You're trying to solve a real-world problem right this second. For instance, figuring out exactly why a specific new product is totally flopping in one particular city. Fundamental research, though, or basic research, takes a much wider view. You aren't trying to solve a specific commercial problem. Instead, you're expanding our overarching map of human knowledge. So studying human behavior just to understand how the brain fundamentally makes decisions, that is a perfect example of fundamental research.
Finally, for this section, let's look at the difference between hard numbers and the human element. Quantitative research is all about the things you can measure with numbers. How many hours do students spend studying? What's the average age of an online shopper? It's the hard data. Qualitative research, however, uncovers the hidden human motivations beneath those surface numbers. It asks why. Why do those students feel so stressed out before exams? Why does a customer feel intensely loyal to one brand over another? Basically, quantitative tells us what is happening, but qualitative tells us why. Both paths are absolutely vital, but they require entirely different tools.
Let's move to Section 3 and see how this builds into one of the most crucial distinctions in academia: method versus methodology.
So the crucial point here is that methodology is the overarching compass that guides the logic of your entire trip. It asks why a particular technique makes sense for your specific study. Methods, on the other hand, are just the specific tools, the binoculars, if you will, that you use along the way. They generally fall into three distinct categories: data collection methods like interviews when you need fresh information, statistical techniques like t-tests to find relationships in your numbers, and evaluation techniques like reliability tests to prove your findings are actually trustworthy. To put it simply, methods are what you do, while methodology is why you do it.
Okay, on to Section 4, the 11-step process.
Now, I know an 11-step process sounds incredibly overwhelming, but don't worry, we're going to logically chunk this down into 3 super manageable phases, so you can see exactly how a project flows from an initial idea to a final thesis. Phase 1 is planning, and honestly, it's arguably the most critical part of your journey because you do this before you spend a single dime. You start by formulating the research problem, which just means narrowing a really broad idea into a specific question. Then you do an extensive literature survey. You read what's already out there to spot the gap, that exact piece of the map nobody has explored yet. From there, you develop a working hypothesis, which is basically your educated guess of what you'll find. Finally, you prepare the research design, drafting a meticulous blueprint of how you'll efficiently conduct the study.
Phase 2 is execution. This is where the rubber really meets the road. First, you determine the sample design, selecting the right representative group from the larger population so you aren't wasting time trying to study every single person on Earth. Next comes actually collecting the data using those tools we discussed a minute ago. And finally, you execute the project. This takes some intense management. If you have enumerators out in the field gathering data for you, you've got to train and monitor them really closely, otherwise your entire expedition could be right off a cliff because of bad data.
And then phase 3 is analysis and reporting. The data's in, and now we have to decode it. We analyze the data by coding it and organizing it into tables. Then we move to hypothesis testing. This is it, the moment of truth. We use statistics to definitively prove or disprove those initial educated guesses we made. If our findings hold up, we can make generalizations, maybe even building a completely new theory. And lastly, we prepare the report or thesis. You're documenting the entire adventure for future explorers so they can read your map and understand exactly what you discovered and how you got there.
Moving on to Section 5, Gathering Data and Sampling. Now, for a really delicate part of the journey, choosing exactly who we're going to study and how we extract the clues we need without accidentally introducing our own personal biases. When picking our sample, we face a major divide. On the left side here is probability sampling. This is where chance decides. Every single item or person in your population has an equal, totally independent chance of being picked. Think of it like drawing names out of a hat. This is fantastic because it keeps personal bias completely out of the equation. On the right, though, we have non-probability sampling. This is where the researcher deliberately handpicks the participants based on their own judgment. And while that sounds incredibly biased, it's actually highly useful and even necessary for targeted, deliberate case studies where you need, say, very specific experts or unique scenarios.
Okay, so once you have your sample, how do you actually gather the clues? Let's rapidly evaluate 4 primary data collection methods. Observation simply involves watching subjects, which completely removes the bias of questioning because, well, you aren't asking them anything at all. Telephone interviews are incredibly quick and cheap, but they inherently exclude anyone without a phone, which obviously skews your data. Mail questionnaires are super low cost and remove interviewer influence entirely, but as we all know, they usually go straight into the recycling bin, so your accuracy suffers because the response rate is notoriously low. Finally, the personal interview is incredibly flexible, letting you rephrase questions right there on the fly, but it requires a massive budget if your subjects are spread out. You always have to balance your budget against the accuracy of the clues you need to collect.
And that brings us to the end of our journey today. As you've seen, research is far more than just piling up random facts. It's a meticulously planned, heavily structured scientific method designed to chase the truth using sheer logic and hard evidence. By understanding the difference between fundamental and applied research, by mastering the methodology behind your chosen methods, and by logically following that 11-step process, you are officially equipped to navigate the unknown. So the only real question left is this: what unknown will your next voyage of discovery explore? I challenge you to apply this structured approach to the everyday mysteries in your own life and academic pursuits. Thanks so much for joining me on this explainer, and hey, happy exploring!